Hey guys, Dr. Brown here from Kubo Math, coming to you from Tarlac City, Philippines, and I can't get the top off my marker. Okay. All right, this video is a Calculus 2 video dealing with the integrals associated with inverse trig functions. And I have one up here, and I'm always curious as to, well, where did that come from? How did they know that the integral of du over the square root of a squared minus u squared equals inverse sine, or arcsine, u over a plus c? Because you're supposed to, when you see this, just write that. So let's just see if we can take that integral and make that happen. Let's get after it. Okay. Well, what to do? Okay, when you see a form like this, you know sine squared theta plus cosine squared theta equals 1. So we could say, well, 1 minus sine squared, for example, that equals cosine squared theta. So you can think, well, that's kind of the same form. So I tell you what, why don't we just take and let u equal a sine theta. Okay, du then equals a cosine theta d theta. Okay, well, let's do a little substitution here. Du is a cosine theta d theta. I'm going to put the a outside. Cosine theta d theta. So a cosine theta d theta over the square root of a squared minus u a sine theta, and that squared. So u squared. So a square root of a squared minus this, which is u squared. Okay? So let's keep rolling here. We still have a times the integral of cosine theta d theta over square root of a squared minus, and we'll go ahead and square this now. That's a squared sine squared theta, still all under the radical sign. All right, let's go up here with this. A integral cosine theta d theta. Now I'm going to factor out one of the a squares here, still under the radical sign. A squared times 1 minus sine squared theta. Okay, so all I've done is factored out the a square. Okay, now it's in the denominator, obviously. So I have, if I go ahead and factor out that a square, I have a over that square root of a square is a, so that becomes 1. Cosine theta over 1 minus sine square theta. Oh, well, that's cosine theta, or cosine square. So I have the square root of cosine squared theta, still integrating with respect to theta. Well, square root of cosine squared is cosine. So that equals the integral of cosine theta over cosine theta d theta. Well, that becomes 1. So I end up with the integral of d theta, which is just theta. Okay, now what? Well, I've got theta. How do I figure out theta? You'll notice that I had before u equals a sine theta. So u equals a sine theta. Divide both sides by a, so I have u over a equals sine theta. So theta equals sine inverse u over a. Wow. So we have all of that integral equals sine inverse u over a plus c, which is exactly what they started with here, or what they said that integral equals. So one down. We'll do some more in future videos to figure out if we can prove if in fact those are correct, which I'm sure they are. But it is interesting to me to figure out and see if we can do that. Okay, why did we do this? All right, we're together, we're trying to build a better tomorrow and do that through math. Okay? Hey, buy a kid a book in school near you. Get involved, okay? All right, guys, that's all for now. We'll talk to you next time. Thanks.